So this test is really short, it doesn't have that much material on it. So we'll practice today, we'll practice again on Wednesday, and we will test on Thursday. So, we're on practice test 1, and we are ready for problem number 4. And these are the sketches. So, the very first sketch is one of our piecewise functions. Okay? So, here we go. One at a time. Our first equation here is basically y equals 2x plus 1. What shape is y equals 2x plus 1? What shape is that? It's linear, right? Plane x, it's linear. So y equals mx plus b. So we'll start at 1. And then our slope, that's our y-intercept. And our slope is 2 over 1, so up 2 over 1, down 2 over 1, however you want to do it. And I end up with that line. Oops, I forgot something. Where's my crack in my picture? Where's my break going to be? 2. At 2. So I'm going to put my, there's 1, 2. Okay, so there's the break. So when I drew my line, clearly it hit the break right there. Open or closed. Open. And keeping, that's not a very good arrow there, keeping that side. So I'm actually going to erase most of my pink because I'm only going to keep that part right there. Okay. Now what shape is this?
OV.
That should be absolute value. Here's where he hits, open or closed. Closed. And keeping the left side. So we'll erase that little piece right there. And if you want, you don't have to, but if you want, you can go ahead and erase your squiggly line. And there we go. That's it. Everybody okay with that? Then we have some more graphs, but these are all just BFFs moved around. Okay, so pay attention. Okay, you know -3 moves you. Pay attention to where that is. See how it's inside the problem? So what does that mean then? When it's inside the problem, it means we are moving to the left or right. And since it's -3, we're going to move to the right. So our V that used to be at the origin is now at the 0.30. Label your starting point, guys, unless it's the origin. You don't have to label the origin, but you should label any place you move your picture, you should label that. Okay? This one is harder. First of all, the shape is a little harder. I'm going to draw my regular sign right here. What does my regular sign look like?
It's like one of those little...
It's the wave, and it's the one that goes through the origin.
But you go
Now, something, yeah, this is the regular one. This is the regular one. Now, I'm gonna take that sine curve and move it down one. Everybody see, it's not this. It's not that. That would move you left or right. That is just down one. So the point that used to be at the origin is now here. Would you agree with that? So that's 0, -1. And then I'm going, there's my hills and my valleys. Oops.
So should that not go over the, should not, that not cross
It
the?
actually shouldn't. I have not emphasized with you all that in this sine curve, it goes up one and down one. So when I drop it down one, it's just gonna go up right up to the axis and not go above. What I'm gonna be focusing on is that point right there. Okay, because that point you do know where it goes, because it was at the origin. Okay, 3 more of those. All right, what shape is this guy gonna be? This should be easy for you. What shape is he?
Square.
Square, and so he's a parabola. And how has he been moved? He's got 2 moves going on. How's he been moved?
Left one.
Left 1 and down 2. So start at the origin, go left 1 and down 2. And you will be at the point -1, -2. And there's your parabola. You guys okay with that? All right, what about this one now? What's happening to this picture? Up 1.
It's gonna be cute.
Now remember, I'm gonna just draw my normal over here. My normal one squiggles right here at the origin, right? So now this one is gonna do that up here. We're moving it up 1. So now the squiggle is gonna happen at that point. So remember, that cubing function, we have a defined squiggle. So it's like you're coming up like this, and then you switch gears and go like that at that point. And one more. What's gonna happen, what's gonna happen to this picture? Gonna go up 2, what else is gonna happen? This right here tells me I'm going up 2, what else is gonna happen?
Over.
Which way over? Yes, it goes over, which way? Right. So right 3, up 2. So we know what the square root function looks like. Origin, up and out. So that point now is over 3 and up 2. Just like that.
So you have to have, to be able to even do these, you have to have like easily everything we just quizzed over.
Yes.
memorized.
Yes, yes,
Which I do, but
because you're awesome.
I'm
Yeah.
always like,
So yeah, you can't really graph these unless you know what the shape is, and they're all your BFFs.
the only one I don't know is the one with like the E and like the I don't know, all that stuff. I got that one.
All right. Keep studying. All right, so we got these 2 functions now. Last section of the test is this function part. So the first question says, find f of 2 plus g of -3. This looks really complicated, you took this home and showed your parents, they would think you were geniuses, but you're really not because this isn't hard, right? Oh, you are geniuses, but this is an easy problem, okay? F of 2. How do we find f of 2? Plug in 2. So f of 2 is 2 times 2 squared plus 1. Square first, PEMDAS, PEMDAS, PEMDAS. Square first, so 2 squared is 4 times 2 is 8 plus 1, so this is 9. And then we'll find g of negative 3. So that will be 3 times negative 3 minus 4, which is what? Negative 9 minus 4, negative 13. You'll be allowed to use a calculator to help you.
So 9 plus 13.
So then we add those two together. That's what the problem says. So the answer is negative 4. All right, same two functions. Problem B says f of x minus g of x. Oh my gosh, don't you dare miss this. What's f of x? 2x squared plus 1. What's g of x? 3x minus 4. And I'm just going to subtract them. Now I do have to be careful. I'm subtracting this whole thing. So it's going to be 2x squared plus 1 minus 3x plus 4. And then I'll clean it up. 2x squared minus 3x plus 5 if I added and did everything right. And then I stop. It doesn't say solve. It's not equal to 0. There's no quadratic formula. I'm done. Right here. Done. What does this mean? What do I do with this guy? It's a two-step problem. Phoebe, remember? It's a two-stepper. What do I do first?
Get rid of the absolute value.
Well, there's really no absolute value here, but if you mean the brackets, yes, I'm gonna do what's inside the bracket first. So what's g of 3? What is g of 3? Look up at your g function, put in 3. What's g of 3? 5. 3 times 3 minus 4, 5. Now, that's this right here. This is 5. So what do I do with the 5? Now I take the 5 and plug it into f. So f of 5 is 2 times 5 squared plus 1. Do not forget PEMDAS. What do I do first here? 5 squared, which is 25, times 2, which is 50, plus 1. The answer is 51. Do not multiply first. Don't do 2 times 5 and then square it. That's wrong. It's 5 squared times 2. Okay, Phoebe, you with us? Okay. All right, last one on this whole practice test is this. Now, it's very much like the one we just did, except we don't have a number. So we're going to take the whole f of x, this whole thing right here, and we're going to plug it into g. So you're taking the whole f of x function and you're plugging it into g. So we're going to have 3 times 2x squared plus 1 minus 4. This whole f is getting put in right here for this x. So if I did my math correctly, I got 6x squared minus 1. Alright, let's go on to practice test 2 and do it all over again. Please do this on the other side of your, notebook paper or giving you sheet, mark it, practice test 2. I won't do this again, from now on, I'll run it off and use a ton of paper. I think it's worth it.
I think we're saving it for right now.
Huh?
We're saving it.
I know we're saving the money. Okay, so this time, the problems are in a little different order than they were on the last practice, but it is exactly the same questions. In fact, we're starting with what we just finished. Number 1. Oh my gosh, we just did this. Can somebody besides me tell us, what do I do here? What does this mean, Mackenzie?
You put in the you put in NX into the X for MX, so like inside
Exactly.
the parenthesis for 4.
Exactly. So we're gonna take the N thing, which is right here, this is the N thing, and we're gonna plug it into M. So we're gonna plug it in right here. So this N function is going in place of the X in the M function. Plug N into M. So the N goes into M. So we're gonna have 4 times x squared plus 2 minus 3. Did you get 4x squared plus 5? Remember, this into this. Okay, m of 2, go back to your original functions there, m of 2. What's m of 2? Izzy, do you know what to do if we have to find m of 2? So it's gonna be 4 times 2 minus 3, what is that? 5? And now we'll do same thing, but we'll put 3 into n. 3 squared plus 2 is 11. And then the problem tells me to subtract those, so the answer is -6. Everybody good? All right, what's this one telling me to do? Put 1 into n, so I start right here, I find n of 1, and n of 1 would be 3.
Yeah.
And then I take the 3 and plug it into m. So m of 3, you get 9, 12 minus 3. And finally, m of x times n of x. Don't make this hard, this is a multiply. So we're gonna take m, which is 4x minus 3, and we're gonna times it by n, which is x squared plus 2. It literally says, kids, multiply them together. So what do you think I'm gonna do to multiply those? FOIL. So 4x to the third, that's out, or first, outside, inside, and last. Does anything there combine? No, no like terms. So I'm a math teacher, so I'm gonna go ahead and put them in descending order, but I'm certainly not gonna mark it wrong if you don't. You're not a math teacher, you don't have the same compulsions that I have. You good? Alright, next one, implicit functions. Who remembers how we do this? We just learned this, this was the last thing we learned. Who remembers how this works on implicit functions? We get y by itself. So I'm going to subtract 2x squared, would everybody agree with that? And then what am I gonna have to do to get y all by itself?
Square root.
Square root. And I'm gonna write two separate answers. Square root of 6 minus 2x squared and negative square root of 6 minus 2x squared. Do I ever change anything inside the parenthesis or inside the radical? Nope, don't touch it. These two are identical, except one's a positive and one's a negative.
Is that your whole answer?
That's the answer, right there. And on the test, there'll be two answer blanks. You'll put this in one and this in one. Josh?
Where did you get 6 minus 2x squared?
Subtracted 2x squared from both sides in order to get y squared by itself. You need to go watch the video, sweetheart, of the lesson that you missed, okay?
Yeah, I will. I'll find that.
Alright, so that's it for number 2. Number 2's done. Number 3, domain. What goes through your mind when you read the words, find the domain? The rules. And what are the rules? What'd you say? Denominator cannot be 0. So let's start with that rule right there. That's a great rule. The denominator cannot be 0. So I'm going to look at my list of problems. The test will have 4 of them, just like this. Let's look at the list. Which ones have denominators? This one does? So 3x minus 1 cannot be 0, which means 3x cannot be 1, which means x cannot be 1/3. Answer right there. Everybody okay with that? Now, do any of the others have denominators? This one? X minus 3 cannot be 0, so x cannot be 3. The denominator, whatever it is, cannot be 0. So say cannot be 0 and solve it. All right? What's another rule? We have 2. What's the other one?
Greater.
Has to be greater than this.
Whatever is under the radical has to be greater than or equal to 0. So in this problem, x minus 1 has to be greater than or equal to 0, which means x is greater than or equal to 1. Be careful, this one, we already did part of it, but it also has a radical. So this is going to have a 2-part answer, right? We're used to that, we've had those before. What about C? I don't have anything written down here. What about C?
Negative infinity.
Yep, that one has neither one of the problems, neither one of the rules apply. So therefore the domain is simply everything, all the numbers. Which we express as negative infinity to infinity, because we're pre-calculus students. Okay. Ready to move on to the graphs now? All right, here we go. First one says sketch this. What shape is this going to be? Letter A, 4A will be what kind of a shape? Gonna be a V. And how is it gonna be moved? Left 2, up 1. So left 2, up 1, label that point, -2, 1, and draw in your okay? Nothing hard about that, except you gotta know the rules and the shapes. Okay, what about this next one? Sine x plus 2. We all know what the sine function looks like. I'll draw it again for you. That's your sine function. Now I'm going to move it up 2. So where am I going to start my picture? Normally I start it right here. I'm going to go up 2. So it's going to start right here. So I'm going to label that point 0, 2. And then I'm going to go ahead and draw my hills and my valleys. The whole thing's been lifted up 2 units. And again, I'm looking for that point and this shape. Perfect. Perfect, perfect. Okay. What about this? What shape is C? It's a parabola. And how's it been shifted?
Down 1, right?
This is down 1. And this is right 1. So here's my, let's see, right 1, down 1. So that's the point 1, -1. X is 1, right 1, down 1. And there's my parabola. Oh my gosh, it's so easy. What about this? What shape is D?
Cubing, so it
That's
goes
the
in there.
cubing, so it's kind of your S curve thing. And normally that curve happens here at the origin, right? What's happened to this one now? How has this one been moved?
Up 2.
Not up 2,
Down 2.
not down
Left
2.
I mean left 2, yeah.
Left 2, there we go. Left 2. How do we know it's left and not up or down? It's in the parentheses. And in the parentheses always means sideways, left or right. So over here, this is the point -2, 0, always label your point. And then squiggle up to here, and that's where it changes and ends up going like that. So there is your shape. Okay, what's the shape of the next one?
It's like it starts there and just goes like out.
Your up and out one. Normally it starts at the origin. Where is this one starting? Which way is it going? Left 1 and down 2. So left 1, down 2. And up and out.
So since it usually goes like up and down with like the original goes in, is it going down this time because of it being negative?
The shape of the curve is this. So that shape is still there. That doesn't change.
Okay.
The only thing that changes is where it starts.
Okay.
And that's because of the movement. The shape never changes, same shape. Okay, now we have our piecewise function, so we've already done one of these today. Let's try this one. Y equals 3x minus 4. And that's, oops. And x plus 1. Okay. So this time I'm not gonna forget, I'm gonna go ahead and put my break right here at -1. That's where my picture breaks. And I don't care if you put that in there or not, but kids, you've gotta remember where to put the dots. The dots are always gonna go on this break line. That's why I like to have it here, because the dots have to be lined up. I'm grading some of these homeworks, and I'm seeing one dot over here and one dot over here. Never, never. They're lined up right on top of each other. And if you have that line there, you'll probably know that. Okay, what shape is this? Remember, it's y equals 3x minus 4. Y equals mx plus b. That's a line, 1, 2, 3, 4, with a slope of 3. It's gonna be way down there. Oh boy. Oh boy. I think I'm gonna draw this again a little bit higher because I'm not gonna be able to see what I need to see. Here's my squiggly line. I'll get it right here in a second, hopefully. Oh, you guys, all my markers are running out. Okay, so now I'm gonna graph my line. There we go. Okay, there it is. I had it right over here, but look, this is where it was gonna intersect, clear down there, I couldn't see it. So here's where it intersects, right there. Open dot or closed, open, and keeping this part. So I'm getting rid of all of that. What's this? That's a V, but what about that V? Pay attention, that V has been moved up 1. So now it's right here. Like that. Open or close dot. Closed. And keeping that part, so I have to erase this part of the V. If you want, you can go ahead and erase your squiggly, but you don't have to, you can leave it. It's fine to leave it if you wish. Are my dots lined up on top of each other? Yeah, just like they should be. Okay, all right, one more part, and then we'll be done with this one, and I'll stop for the day, once we get done with this. Okay, so now we have the part where we have to figure out, oops, our asymptotes and holes. Ooh, it fell down in the cobwebs. Yeah. Okay, so let's look at this first problem. And you're gonna tell me the vertical asymptote, horizontal asymptote, and holes, okay? That's what you're gonna tell me. You can draw it if you wish, but you do not have to. Okay? So what can you tell me about the holes right away? There aren't any. How do we know there aren't any holes?
Because we're not squaring.
Because because we're not going to cancel anything. Make a notation if you've forgotten that. Holes come from canceling. If you can't cancel, you can't have any holes. Do we have asymptotes? Yes, we do. What do you know about those? Either one, vertical or horizontal?
Wait, is one of them 4?
Is one of them 4? No? But I think I know what you're thinking. Vertical asymptotes come from the denominator. So 3x minus 4 can't be 0, would you agree? Which means 3x can't be 4 and x can't be 4/3. That is your vertical asymptote. The cannot be, when you say x cannot be something, that's your vertical asymptote. So if that 3 hadn't been there, it would be a 4. But because of the 3, it's a 3/4. Okay, perfect. Come from the denominator, verticals.
The 2/3.
Y equals 2/3. Where do these come from? Boxing in our x's. Remember that? Okay, next. What do you think we ought to do with this guy?
You have to factor this
Yep.
out, and then it will have a hole.
I think it's always a good idea, kids, to factor. In this particular problem, it's not really going to help us. It's not gonna hurt us, but it didn't help us because even though we could factor, still nothing will
There's
cancel.
nothing to cancel.
So once again, we're going to have no holes. Because holes can only happen if you cancel. Tell me about the asymptotes.
VA is negative.
The vertical asymptote is at x equals -5 because verticals come from the denominator. So -5, okay. Where do horizontals come from? Boxing. But be careful. Remember when you box, you have to make a match, right? So I don't have an x squared in the bottom, so I put a 0 down there. What's anything over 0? No solution. So there is no horizontal asymptote
But
either.
the 0's on the top, would it be 0?
Yes. 0 on the bottom is no. 0 on the top is 0.
When you're doing vertical asymptote and you set it like it does not equal this number, well 0, how come when we put it down for the answer, we put x equals? instead of
Because
not
we
equal?
are actually drawing the line, and the line is the line x equals -5.
Okay, so don't put the does not equal.
Don't put the does not equal. Now, if you accidentally do, because that's a domain thing, we would
Yeah.
put that for a domain. I'm not gonna mark it wrong, but technically, it's x equals -5. All right, one more, guys. One, oh my, oh my. Okay, well, what do you think about this? Here, marker to fix. Okay, what are we gonna do with this guy? He's huge.
First, you're gonna factor.
First thing, let's start factoring stuff. So what can I do in terms of factoring?
For the top one, we're gonna pull out, did you see?
I would definitely pull out a 2, and that leaves me with x squared minus 16. And what do I know about x squared minus 16?
X minus 4, whatever it is for.
So 2x plus 4, x minus 4. Okay. How about my denominator? Can I do anything with my denominator? answer is yes.
Yeah, you can,
How does it factor?
it'd be like negative, no.
-4 plus 5.
X minus 4x plus 5. What do you think about that, folks? I think she's right.
Yeah, and you can't cancel.
And now we can cancel. So we're going to ultimately graph 2x plus 4 over x plus 5. That is what we are going to graph. But because we canceled, we are going to have a hole. Remember, the asymptotes are equations. X equals and y equals. The hole, though, is a point. The x part of the point comes from where?
The 4.
The 4. What canceled out? So we canceled out x equals 4. 4. So we're gonna put a 4 here. Where does the y part come from?
Why would you put negative?
It's always the opposite.
Oh.
Always the opposite. Now, put the 4 back in here now. So we're gonna have 2 times 4 plus 4 over 4 plus 5. So that's 2 times 8, 16 over 9. So your hole is at the point 4, 16 ninths. Now look at your problem. Do we have a vertical asymptote?
So for x, we just do x minus 4 equals 0, and then for y, we plug in the 4 into the original problem. Okay.
Okay, so where's my vertical asymptote?
Is it -5?
It's x equals -5. Where do vertical asymptotes come from? Denominator.
So you said equal to
What's in your denominator? X plus 5. Set it equal to 0 and solve. How about my horizontal asymptote?
2.
So we're gonna box in, and you can either box in the original problem, or you can box in right here. It doesn't matter. Either place, you have 2 over 1. So your asymptote is y equals 2. All right? Now, we just did like a test and a half, plus took our quiz. So next time, we'll definitely get the second or the last practice test done, and then we'll have time for whatever kind of random questions you might have.